Now let's understand Kirchhoff's laws. There are two laws. Although we are using it, whenever we are solving problems, we are using it, but let's understand them properly. There are two laws of Kirchhoff's given by Kirchhoff. Kirchhoff's laws. First law is called current law or junction law. For C, it is written as Kirchhoff's current law, KCL. Second is called voltage law or loop law. So for this V, we write it as KVL. Okay. Now let me explain what is KCL and what is KVL. The terminologies I have told you. If you have a circuit, let me draw us a big circuit. So there are so many resistors, so many voltage sources. Let's say this is V1, this is V2, this is V3, this is V4. Let's start numbering in this direction only. Let this be R1, R2, R3, R4, R5, R6, R7, R8, R9. So let this be a big network. Now, I'll explain Kirchhoff's current law. First of all, KCL. Kirchhoff's current law states that at any junction, all the incoming currents, when you have the algebraic sum of incoming currents is equal to 0. What is the meaning of this? What is a junction? Junction is this, where you have, branches, where branches meet. This is a junction. This you can take it as a junction that this and this is meeting, but generally at least 3 branches when meet at a point, we say it is a junction. So this is another junction, this is another junction, this is another junction. Now let's say our current is at this point. Let this be junction A. At this point, let's say this is our I1, this is I2, and this is I3. I told you algebraic sum of all incoming currents is 0. So incoming current you will take positive. This is outgoing. I3 is also a positive, but I2 is outgoing. See, I1 is entering the junction, I3 is entering the junction, but I2 is leaving. So I2 will be negative. I2 plus I3. This will be equal to 0. This is Kirchhoff's law, current law. Okay. Similarly, if you say this is I4, this is I5, this is I6. Then entering currents are I4 and I5. So I4 plus I5, I6 is outgoing. So minus, this is equal to 0. So this is KCL at this point. Similarly, if this is I6, see, this is I6, this is I1. Let's say this is I7 and this is I8. Only I6 is incoming. So I6 is positive, I7, I8 and I1 all are negative. So this is 0. Okay. This is Kirchhoff's current law. And when you have to take current, don't try thinking over whether this should be the direction of current or this should be the direction of current. You take any direction when you calculate. If, for example, if I have taken I1 to be incoming, after calculation, if it is actually in this direction, you will find I1 negative. You will get result as I1 equal to minus 3 amperes. This means the direction we have taken is wrong. That direction is in this direction. This is only to be taken into consideration. Now, let's see the second one, Kirchhoff's voltage law. I'm rubbing these all. First of all, let me explain and then we'll find the currents using KCL and KVL. Okay. So we have this circuit. This was our R8. Okay. Now Kirchhoff's voltage law. Kirchhoff's current law. According to current law, all the currents, algebraic sum of incoming currents is 0. Kirchhoff's voltage law say that in a loop, the algebraic sum of voltage drops around a loop in a closed loop is equal to 0. Loop means if you start from here, this is a loop. Okay, we must take one resistor here also, otherwise this will be short circuit. So we have reached up to R8, R9, so let this be R10. Okay, so this is a loop, closed loop. This is also a closed loop. I'm taking another color pen, let me check. This is a loop. This is a loop. This is also a loop. If you talk of this hole is also a loop. So these are called closed loops. According to Kirchhoff's voltage law, the voltage drop across a loop is equal to 0. So what is the meaning? Let's say this is our loop. Let's say a current I is flowing in this particular loop. This is the way we take. So in this loop, Kirchhoff's voltage law says voltage drop across this. See, this is current. So I is entering here. This will be plus, this will be minus. This is a cell, so this is plus minus. I is entering here, so this is plus, this is minus, again plus, minus, plus, minus. So you take in this direction. First is R5. So R5 into I. This is the voltage drop across this resistor. Then you have V. Then R4 into I. Then R10 into I. And finally R7 into I. This is 0. Let's say we talk of a loop which is this one. Let's say this current is I1. So what happens? You have plus minus, current is entering. So plus minus, plus minus, plus minus, and this is minus plus. So this loop will be R6 I1, R6 I1, then see R7 I1, R9 I1, then minus to plus. So minus V1 is equal to 0. This is Kirchhoff's voltage law. Now, when you are studying this for the first time, you'll think I current is flowing here and I1 current is flowing. Correct. We consider the component of the current because of this loop, that is I. Similarly, component of the current in this resistor because of this loop is I1. So if you talk of what is the actual current in this through this resistor, this will be I minus I1. I is in this direction, I1 is in this direction. Whichever is larger, so I minus I1 will be the actual current flowing through it. Okay, clear? So we can solve this. We'll have another equation for this and then another equation for this. You'll have 4 currents, I1, I2, I3, I4, let's say, and you'll have 4 equations. You'll be able to solve them and get the values of current. Okay, or alternatively, if you want to solve through current law, what you'll do, you mark all I1, I2, I3, I4, and then at each junction you'll have to put the value this plus this plus this is equal to 0, this plus this. So then equating them all, you'll get the values of all currents. Clear? We'll see some questions and understand. Let's say we have a circuit, okay, like this. We have to find current and all. Since this is a circuit, a single current I will flow through this. Let's say the direction is this. You can take direction like this also, whatever pleases you. If you will take the wrong direction, the answer will be negative, so that you can rectify your answer. So let's say I current flows, that is I is in here, I is here, like this. Let's start from this in a closed loop. I told you Kirchhoff's voltage law. So because current is in this direction, voltage will be like this, plus minus, then plus minus, then plus minus across the resistors. Let's see what about the current. So from here, I into R, that is I into 1. This is voltage drop across this resistor. Then this is minus to plus, so minus 6 volts. From here, see I into 3, I into 3, then minus to plus, minus 3, then I into 2. We have reached this point, so this is a closed loop now, this is equal to 0. Now let's take I's at one place. So what you get? 1, 3, 4, 1 and 3, 4, 4 and 2, 6. So we get 6I minus 6 minus 3, 9 equal to 0. Therefore 6I is equal to 9 and I is therefore equal to 9 by 6 amperes, that is 3 by 2 amperes. It is a positive, that is the flow of current is like this. Okay. Now let's solve another example. Let's put another loop here. Okay, let this be 2 ohms, this be 3 ohms, and this be 3 ohms. So I told you we'll take two loops, different loops. This is I1 and this is I2. Okay, and we'll take the equations. So this first loop, it is I into 1 minus 6, then up plus 3I minus 3 plus 2I, sorry 1, I1, 2I1 equal to 0. Is this correct? No. Why? When this branch was not there, the current was I only, so we took I into 1. But now we have I1 in this direction. See, I1 is in this direction and I2 is in this direction. So when you take this flow of direction, the current in this 1 ohms resistance will be I1 minus I2, not I1. So this will be, here I have written I1. In place of this, you'll have to write I1 minus I2 into 1. Clear? Now second loop. Let's start from here. Here what we will do, we will take I2 minus I1, this side current. So 6 volts plus 2 minus, then I2 minus I1 into 1. Okay, then I2 into 3. Then here minus 2, so this is minus 3, then I2 into 2. This is the second loop. Now let's solve it. First equation. See, I1, 3I1, 4I1, 6I1. So 6I1 then is minus I2. So we have used this is equal to minus 6 minus 3 equal to 0. So 9. This is our first equation in I1 and I2. And from here what you will get? See, I2 plus 3I2, 4I2 plus 2, 6I2. So we have 6I2. And what about I1? This is minus I1 only. Minus I1 is equal to, see, 6 minus 3 is plus 3. So this will be minus 3. So we have got our two equations. We can solve it. How? Let's multiply this second equation by 6. So this will be 6I1, this will be 36I2, this will be 18. Now add these two, this cancels this. So this is 35I2, this is minus 18 plus 9. So this is minus 9. So we get I2 as minus 9 by 35 amperes. And from here, from any equation, you can get I1. You have I1 equal to 9 minus I2, 9 plus I2. So 9 plus 9 by 35, not plus, this is minus. So 9 minus this by 6. So this is the value of your I1. Clear?